This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 2, Lesson 10, The Heating and Cooling Loads Capstone. No new theory. You already own every piece. Envelope conduction, fenestration, people, lights, motors, appliances, infiltration, ventilation, and the standard air factors that turn any airflow into a load. This lesson is the method under exam pressure. Identify each gain, reach for the right printed equation or table, and sum by type. We'll build one small office's block load in 4 moves: a wall and window, the internal gains, the outdoor air, then the assembly into a peak load, sensible heat ratio, and supply airflow. The load map, 3 moves on every load. First, identify every gain acting on the space: the envelope, the windows, people, lights, motors, appliances, the air that leaks in, and the air you bring in on purpose. Second, route each to its printed equation or table and split it into a sensible and a latent part. Third, sum by type. Take the sensible heat ratio and size the supply air from the sensible load. 2 engines do the heavy lifting: UA delta T for every surface and the standard air factors for every airflow. Problem 1. A sunlit wall with a window, summer design, a 20-degree difference. The opaque wall is the U factor you built in Lesson 2, 0.067, over 120 square feet. UA delta T is 161. The window carries 3 terms, but count its leakage once with the outdoor air later. So here it's conduction 300 plus solar 2400, 2700. Wall plus window, 2861, all sensible. And notice solar alone is most of it. On a sunny day, the glazing coefficient rules, not the U factor. Problem 2. The same office's internal gains. 10 office workers give 2450 sensible and 1550 latent. 2000 watts of lighting times 3.412 is 6824, all sensible. The 1 horsepower fan, motor and fan both inside, is power over efficiency times 2545, about 2994, sensible. Sum the sensible, 12,268, and the latent is people only, 1550. No cooling load factor exists to discount these. Problem 3. The outdoor air. 400 CFM of ventilation at summer design, a 20-degree and 7 thousandths difference. Sensible is 1.1 times 400 times 20, 8800. Latent is 4840 times 400 times 0.007, 13,552. Total, about 22,350. The latent beats the sensible. Humid outdoor air is a low sensible heat ratio load. Mechanical outdoor air pressurizes the space, so infiltration is minimized, and we count outdoor air once. Problem 4. Assemble the block load. Space sensible is the wall and window plus the internal gains. 15,129 with 1550 latent. Add the outdoor air at the coil. Coil sensible, 23,929. Coil latent, 15,102. The block load is 39,000, about 3 1/3 tons. Then size the supply air off the space sensible at a 20-degree supply rise, 688, comfortably above the 400 of outdoor air. Watch the 2 sensible heat ratios. The space value, about 0.91, sets the supply air line, while the coil value, 0.61, is moisture heavy from the ventilation and is what the equipment sees. The week's traps in 1 screen. On surfaces and gains, keep resistance per square foot and bring area in once. Count both films. Solar has no delta T and gives gain only. Only people carry latent, and 3.412 is per watt, while 2545 is per horsepower. On air and assembly, the factor is 1.1, not 1.08, each paired with its own difference. Count leakage once. Infiltration is the residential leakage area method only. There's no cooling load factor or climatic table in the handbook. And the space sensible heat ratio sizes the supply air, while the coil value, with outdoor air, is what the equipment sees. Lookup discipline. The whole week lives in one neighborhood, Chapter 9.1. The standard air factors, the people table, lighting and motors, appliances, the interior UA delta T form, the R value data, fenestration, the glazing tables, insulation, and infiltration all sit there, with a jump to Chapter 5 for the resistance machinery, and Chapter 7 for sensible heat ratio. Know which section, jump to it, read the row, and confirm. Never search from scratch under the clock. The method and the clock. Before you compute, list every gain. Envelope, windows, people, lights, motors, appliances, infiltration, ventilation, because a missed line is the usual lost point. Route each to its pill and split sensible from latent as you go. 2 engines, UA delta T for surfaces, the standard air factors for airflows. Then close it, sum each type, take the sensible heat ratio and size the supply air. Keep 1.1, keep the units the factors expect. Count leakage once, add ventilation at the coil, and if a method isn't printed, the problem gives you the number. That's a wrap on Week 2, Heating and Cooling Loads. 10 lessons across Chapter 9.1, Load Fundamentals, Envelope Conduction, Fenestration and Solar, Internal Gains from People, Lights and Motors, Appliances and Kitchen Equipment, Infiltration, Ventilation, and Pipe and Duct Insulation. Then this capstone tying them together under time. More HVAC weeks are on the way. Subscribe so the next one reaches you. Everything's at PEPrepEngine.com. A cheat sheet, work solutions, and a short quiz are attached here. If the course helped, please subscribe, and good luck on exam day.
The full study guide with every equation and common exam trap is free at PEPrepEngine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.